Wrapping up our kind of online only members meetings. We've had a good set of kind of foreign to Nashville folks from all over the US. And tonight, I am very happy and glad that I could get Paul Berger to come in and speak to us. Paul, can you hear me? You want to take over and start sharing your screen?
Yeah, I can hear you fine. Can you hear me?
Yes, sir.
Okay, good.
Thank you for coming tonight.
No problem. Let me see if I can.
Paul is a longtime caver and a geologist, uh, a big part of like Lechuguilla and Carlsbad Cavern surveys and Fort Stanton and a whole bunch of other really cool stuff. And so anyway, it looks like he's ready to go. So everybody, Paul Berger.
All right, now are you guys seeing my presentation?
We are. You're good to go.
Okay, good. I never know which slide or which screen you guys are actually seeing since I've got 3 attached to this one.
Just a quick legal reminder for everyone, we are recording this. So if you have any problem with that, then please drop. So thanks. Sorry, go ahead, Paul.
Oh, no problem. And I have no problem with it being recorded. So what I'm going to talk about today is just some cool exploration that we've been doing up in Brent Land Bridge National Preserve up here in Alaska. Some pretty cool stuff. As the title slide says, it's the northernmost lava tubes in the US, at least as far as I'm aware, at least as far as I've found anyway. To kind of get you oriented, this is Alaska. For those of you who don't know what Alaska looks like, I can't tell you where your member is paddling around. I don't have a dot for that, but I'm based in Anchorage, which is there in South Central Alaska. And what I'll be talking about is the preserve, which is managed by the National Park Service. And it's on the Seward Peninsula, which is that thing that sticks out there. And then our main travel hub, sort of the closest place you can fly to that is the city of Nome, which is famous for being the end of the Iditarod sled dog race. Just kind of a geology overview. This is just zoomed into basically it's the Emmerich lava fields. And what's shown there in pale blue is the Lost Gem lava flow, which is the most recent. So the whole area is an active volcanic complex that's been going for 26 million years to recent. There's over 110 cubic kilometers of material that's been spewed out. And the Lost Gem lava flow itself, the one that we're concentrated on, is only 1,500 years old. So there's actually been humans on this landscape for more than 10,000 years. So there are actually native accounts of the lava actually flowing. It's not really all that old, relatively speaking. This is another kind of zoomed in view of the lava field. You see it's kind of in that pale gray. It's about the only thing not covered completely in tundra. And as just sort of a scale representative, what I've got shown here is Lava Beds National Monument. For those of you who are familiar with that, they're in Northern California, Southern Oregon. And these are to the same scale. So the lava field, just one lava field itself, is actually larger than all of Lava Beds National Monument. Just to give you kind of a scale of what you're looking at, is this flow is bigger than that whole monument. What I've got shown here is this is the area that we've worked so far. You can see it's a very tiny piece of what we've done so far. It's an extremely remote location. As you see, there are no roads. There's no trails. There's not really much of anything close by. So this is kind of the logistics of getting there. We fly to Nome, and then there's basically 100-mile long dirt road of varying condition that goes out to a landing strip. And the road is only there because there's some placer mines that are still operational in that area. And then from there, we fly in these small helicopters out to the field site. It takes a lot of helicopter runs to get there because these small helicopters can't really carry all that much cargo. So we pretty much, it's sort of two people plus the pilot, and then the personal gear for those two, and then the pilot has to come back and get the rest of the caving gear there, caving and camping gear. This is the landscape leading up to it. You can see that it would not really be practical to hike into the area. You could do it, but it would require bringing a lot of pack rafts and a whole lot of walking through soggy tundra, which if your knees are as bad as mine, you would not last the 3 or 4 days it would take you to get to the lava fields. This is our base camp. We've got set up there on the left is sort of the camping setup. We have to pitch the tents in these little kind of tundra areas because it's the only place soft enough for you to actually get stakes down. And it is reasonably windy here, so you do have to stake the tents down. You can't just pile rocks on. Otherwise, you know, your tent is going away. And even if you were to find it after rolling over all the lava, it would probably not be all that useful. And this is not an area that's really recommended to just sort of sleep out under the stars. Between the bugs and the weather, it would not be very pleasant. The picture on the right is kind of our kitchen area. As is normal for Alaska, you don't locate your kitchen area within 100 yards of your tent. And that's because of bears. There are lots of grizzlies around, though they don't frequent the lava fields all that much because there's not much for them to eat. But we do keep all of our food and stuff in bear barrels, but also a long way away from where we're actually camping. We do, you know, obviously bring in all of our own food, water. There are water sources there, and you'll see some pictures of them. Most of them are in the lava tubes. So even though it's pretty desert environment on the outside, there is actually potable water. We still boil it, but it's almost certainly potable straight out of the ground. So this is our kitchen setup outside of the wind. And then these are just sort of, this is a general view of the landscape that you're looking at. It's a mix between the which is the kind of rubbly, sharp lava, and the Pahoehoe, which is the, relatively speaking, smoother kind of ropey type lava. You know, obviously this area is subject to a lot of freeze thaw, so there aren't any real smooth surfaces. And then you can just see, you know, there's lots of these collapse features all over. And in this particular case, I had done a separate trip with one of the Park Service lichenologists to this area, and was able to actually GPS a bunch of locations that we went back to map on this one. So this one, we weren't really doing a whole lot of new ridge walking. We were able to just go to some of the sites that I had already plinked down on the GPS, which was good because there were, most of the days we were there was really less than about 30 feet of visibility. So we wouldn't have been all that productive if we had just sort of gone out there blind. You know, this is Ellen Whittle, one of the expedition members. She and Ian are both right now in Wyoming, but they're Montana cavers. And this is just your kind of typical ridge walking day out on the field. And you kind of get a biased perspective because most of us didn't take any cameras out in the bad weather. So you see lots of pictures and it looks like we had great weather the whole time, but that was only because we didn't take it out in the bad weather. Again, another landscape shot, just, you know, ridge walking our way across the lava flows. This was more typical the weather we had. And as balmy as this looks, it is not. It is very cold, still above freezing, but you were getting soaking wet in the fog, and it was probably in the low 40s, even though we were there technically in the summertime. These are north of the Arctic Circle, so there's only so much warmth you're going to get. This is kind of the group shot other than me. That's Johanna Kovarik, Ellen, and then Bonnie and Andy Armstrong, and then Ian Checkett at one of the entrances. This is the entrance to one of the longer caves, which is actually part of a series of collapses all along the same tube that we called Valhalla. This is just the map of that series. The kind of longest segment was actual Valhalla, and it's named after kind of the remains of a small rodent inside that we were pretty sure is a bowl of the main cave. And then you'll see a whole lot of names that are variations on the word gnome, since that's what we flew out of. So there's the cave number 52 is wrong number, and you'll see a bunch of these other ones in there. But again, you can see this is just sort of a one long segment of lava tubes. You know, the whole surveyed length of this whole system is probably less than 700 feet. So you're not looking at super long caves yet, but it's still a fun area to go and look for. And then the blue that's shown there is ice, not water. This is looking inside the cave. You know, there are, you know, as you expected, lava tubes, lots of these little skylights. You know, some of the passages were actually nice sized walking passages, you know, up to 40 or 50 feet wide, you know, a good 20 feet tall, you know, all your typical lava tube features. And there were quite a few that were fairly crawly. This is the Vol for Valhalla, partially frozen, but definitely not having a good day. And this particular cave ended in an ice plug that ends up underneath the breakdown. And you can see we're pretty much, you don't switch from outside clothes to caving clothes. You're just wearing your rain pants and Gore-Tex and stuff all the way through. Ian here completely shredded his both pairs of rain pants that he had brought on the trip, and it was down to held together by duct tape by the end of the trip. These are just some of the other entrances that we went to. For all of these, we took GPS locations at both entrances when there were a through trip, and that's because being in the lava, there's enough iron in the basalt that it throws off the compass. We tried doing the disto calibration inside, and the closest we could get foresights and backsights with the disto X's were within 11 degrees. Which is obviously not what you would normally go for. But fortunately, most of these caves had two entrances. So we would just lock down both ends and tie the survey to that. So when I drafted the maps, I kind of like reoriented everything to real world coordinates, and just use the disto stuff inside for sketching. One of the other features that we found on the previous trip, and we documented more on this, there are actually these very large cairns that have been set up on the lava fields, and these larger ones that are kind of the top two here, we're pretty sure that the natives built these for navigation across the lava field to get them from the tundra on one side to Emmerich Lake on the other, where they could actually, you know, do fishing and hunting, because otherwise it's a pretty featureless landscape. We could see from any of these cairns, you could look across the field and just sort of silhouetted see another set. So it looked like that's where these cairns were going. The one in the this lower one is a cairn that's set up over a cave that actually has fresh water in it, and we think that's why that cairn was there. Based on the size of the lichen growth that's on these, and having had the lichenologist with us on the first trip, he was estimating that these cairns are at least 1,000 years old. So these were not built by anybody recent. These were actually very, very old cairns that were built for the navigation. So that was pretty cool to realize that the native Alaskans there were actually using the water sources on the lava fields. That we have not found any, other than the cairns, not found any other archaeology in the area that we've been working. You know, as well as the big lava tubes, you also have kind of these surface tubes. You know, these are just sort of like later flow blisters. They're usually, you know, only like, you know, 10 to 15 inches high, and kind of cruise around the top of the landscape. They don't get very deep, but they're kind of fun. We were just calling these karst features, you know, even though they're not. This isn't karst. You can still call it pseudokarst, but these weren't the main caves. But we did map quite a few of these that were, that pretty much anything that was over 10 meters long, we went ahead and mapped just to document. And more of the features. In some cases, you're dropping down between, kind of breakdown that's just choked, into the lava tubes where the main ones aren't shown. There's all these big lava blisters, like up in the upper right, across there. Absolutely gorgeous lichen. If you enjoy lichen, this is a really cool place to be, because the surrounding landscape is so rough that the caribou don't really come in and graze on it. So it's well, as the lichenologist called it, he said it's the one place in Alaska where you can find old growth lichen, which most people don't really think of it as old growth, other than giant trees, but it is still really cool. One of the areas that was actually new that we found this time that I hadn't already found on the previous trip was an area that we called Hobbiton. It's a cluster of these really cool caves. Obviously, they were probably part of one larger system. There's just a lot of collapses in between, but it's a complex of several caves. And this is kind of their relative layout between each other. Again, the blue that's shown is ice, not water. The largest one was the one we called Wormhole, and that's because there was this tiny little worm crawling on the lava inside the cave. It's probably an endemic species. We don't have any invertebrate folks with us that that could really identify the things. And I'm a geologist, not a biologist, but this was the longest single cave that we mapped, was Wormhole, which was just at 618 feet, or just shy of 200 meters. But a pretty nice complex cave, reasonably decent passage, at least for that area. These are some views from the inside, and then the lower center is the actual worm of Wormhole. And then some views looking out some of the skylight entrances. And for scale, what you're looking at there is a disto, to show you kind of what the size of that worm is. And like I said, there's several of the caves that had water in it. This one is the picture on the left. This is the one that we called Spanish Cave, and you can see just to the left of Ian there, there's red lichen growth that actually looked like a Maltese cross. And then on the inside of that one, there was actually this nice pool of water. And then what we found was, going around the lava tubes, a lot of them had water in them. So even though we brought enough water to last us the whole trip, we really did have plenty, which was always nice. This is again another map of one of the bigger complexes. In this case, the blue is actual water. Just kind of more example of the caves that we were finding. And again, this is one lava tube feature that's, because of collapse, been divided into several other caves. And this is Pillar Basalt Cave. It's one of the few that have the really nice lava sickles on the ceiling. And this one was just named for that kind of pillar that's in the middle of the cave next to Andy there. And some of these don't really have real names. LJ just means Lost Gem, and then the number is the number of the feature. So there's nothing magic about those numbers. We're Park Service, so we just assign everything numbers, letters, things like that. But with the water in a lot of these caves were pretty nice. You certainly wouldn't go swimming, but this is one of the longer caves. This one had a segment and then a big open area on the surface, and then another long cave segment. And the name there, if you can read it, it's pretty fine print, but it's basically in the native language means need a boat cave, or boat ride cave. This is the collapse feature on the surface. It's full of water, and then you've got the main entrance there, and then on the inside, which is the same as the cover shot, we were able to do a shot basically 200 feet to the back of this collapse. Nobody had the gumption to jump in and swim to make sure it was a dead end. Sort of most of us in retrospect have been sitting there going, why didn't we just do that? You know, it wouldn't take that much to go there. You know, I mean, the water's just above freezing because there's actually ice below the water. But had it been a sunny day on the outside, we may have been more tempted, but it was one of those gray, gloomy days. So you'd be in water that was just a skosh over freezing and then come out in 48 degrees. So as much as we all want to talk like we should have been heroes and done it, there was no way anyone was going to swim this. So this is one we could go back to with something like a pack raft. But that the far end of the collapse corresponds with another chunk of the collapsed sinkhole on the surface. So it probably doesn't go anywhere. Most of the ones in here are just one long tube. So we wouldn't expect there to be a long branch, but it's still, you know, really enticing to see that. And then you can also see kind of some of the former water lines up there above Andy's head. So, you know, at one point someone could do a nice chilly sump dive if they really wanted to. That won't be me, but somebody could. It's another view of the
Wilson Chrissy Richards.
This is another view of the same cave, basically from the position that Andy was sitting. So we were out there for a total of 7 days. The whole expedition was 10 days, but you kind of have a lot of logistics on either end. And this is our pilot coming in to rescue us. We were actually thinking we might end up stranded for a couple of extra days because the clouds had come in the morning and it was back down to like 10 feet of visibility, which meant they couldn't land. But luckily by around noon, the skies lifted enough that we could get the helicopter in and get out of there before getting stuck. It is very typical for any of the operations in Alaska, both caving wise and just Park Service wise, that we always bring at least 4 days of extra food, just because you're dealing with these kind of logistics, and you know, you can really stretch 4 days worth of freeze dried to 8 days if you need to, especially if all you're doing is kind of hunkered down in your tent. But basically we mapped 34 caves and then documented and mapped another 25 karst features, you know, those little tubes. Just under, you know, 4,000 feet of cave passage that's mapped, and you can see the green dots there show kind of the caves that we mapped and how much area is still left to do. And then of course 3 sets of rain pants and jackets destroyed at least on that. So, and these are sort of, everyone gets their own hero shot at the end. That's me on the upper left, and then Johanna, Andy Armstrong, Ian, Bonnie, and then Ellen. So everyone gets their own cave or cave entrance shot. And then all the photographs were taken by the crew. And then I always have to thank, you know, our helicopter pilot, Corey, who not only picked us up and dropped us off, but every time he had to cross the area to do a different mission, he actually flew over to make sure we were doing okay. He would fly over and check on us, which we appreciated. And then a couple of the NPS people that helped support the flight logistics and get the expedition going, including a significant amount of funding support from the park up there to get this operation going. And then we also had some support from the Sarah Corey Fund, the U.S. Exploration Fund. And with that, I will put in the lava flow sunset picture and open it up to any questions anyone might have.
I have a question, Paul. Did you, you may have said this early on and I forgot, but how old are these lava flows?
The main lava flow that we're on is 1,500 years.
Okay.
The whole lava complex is 26 million years old.
This
Great
is-
talk, Paul.
Thanks, Josh.
You know, I definitely, I was hoping, I liked your answer as far as picking tubes with 2 entrances to make your survey come out right. I was hoping you had some kind of magical formula that you were going to spurt out to us to tell us how to map lava tubes easier, because I've tried it and it's very difficult, and 11 degrees is pretty good from the day or 2 I've done trying to do it. So anyway, it's a tough task.
Yeah, it's definitely a challenge, and we couldn't really even calibrate the distos on the surface because you're still sitting on the lava, and all it meant is it was harder to see the red dot.
Right. How many expeditions
I
like
had a-
that do you do a year?
Basically, this was the only one we've done up there. The total cost of the operation up there was over $10,000. So it's not something that I can do out of pocket. I pretty much have to wait for the park to have maybe some extra money at the end of the year that they can put towards it, or something, because it's not a super high priority for the caver, or for caver budget. The Sarah Corey Fund obviously isn't going to put that much money into an expedition. And then there's really no practical way of kind of divvying those kind of costs up with the cavers to make it reasonable. But what I try to do up here, because unlike you guys who can hop in your car in the afternoon and go jump in a cave, there's nowhere up here that doesn't at least require some kind of airplane flight to get to a caving area. And it's usually a commercial flight to someplace and then chartering either a float plane, tundra tire plane, or helicopter to get to the site. So it's actually cheaper for me to run down and work on my projects in the lower 48 than to work on my projects in Alaska. But I try to do at least every other year a cave expedition up here, and I do it between several different areas. I've got some projects in Glacier Bay National Park. There's a couple other areas in Bering Land Bridge National Park and Preserve that I've done some work in. So it just sort of, I try to mix it up so where I'm not going to the same place every time. I would love to do one of these kind of expeditions every year, but it's just not feasible. Yeah, well, it's money and also time, because we have such a short field season here, and I do have to be aware of my responsibilities for the day job. And I'm out helping the parks on water issues most of the summer when there's no COVID going on. So I'm usually stretched pretty thin over the summer. I think somebody else had a question.
Examples.
I had a question about the actual nature of the lava rock. And does the rock have any differences to like our normal rocks we're normally caving in? Like in sharpness, or do you feel like it's just as stable? Never caved in lava tubes. I'm just curious as to, was there any differences that you noticed?
Yeah, I mean, there's certainly a lot. I mean, just fundamentally between lava and limestone, lava is way more rough. It's there is even the lava that's sort of we speak of as being the smooth type of lava. It's still something that would be rougher than you'd want to crawl over without knee pads or anything. It's basically like a rock made out of Brillo pad. Or Brillo pad made out of rock, whichever way you want to look at it.
Does it break off easier? Did you feel like it was stable? It being like
it's really just as stable, other than breakdown is breakdown. So
right.
That's always going to be loose. And when you're talking about virgin cave, it's just as loose as any other kind. But like walking around on the surface, we're not really concerned that we're gonna fall through into a lava tube or something like that. So there are some thin crusts on the surface, but you're just kind of crunching. You're not really like breaking through and stuff like that. So it is pretty stable. We were never really concerned that about thinking about collapse or anything like that, other than around the breakdown areas. And that's pretty common in whatever rock you're in, that the breakdown areas are the ones you make sure you're most careful around.
And piggybacking off the rock question, I noticed in the picture that had the long water flow that you guys didn't jump into in the freezing cold, there was some color on the rocks there. Was that because it was close to the surface, or I couldn't tell? Is that lichen growing within the rocks going in? Was that the entrance right behind?
Yeah, that cave, that picture is all lit by the natural light. That wasn't a flash. So that is the sunlight coming in. So,
okay, was that lichen, or was that just the color of the?
Yeah, that's all lichen.
Okay, it's really neat. It's very colorful. It was very noticeable.
Yeah, the reddish stuff you see further in is kind of your typical lava type coloration. The red comes from the devitrification of the volcanic glass. It just gives it a red hue. But most of those real bright colors you see around the entrance are definitely lichen.
Hey, Paul, what volcano and/or volcanoes is this lava originated from? Is it offshore underwater now, or I don't know if you could answer that, please.
Yeah, amazingly enough, the Lost Gem lava flow comes from the Lost Gem cone. I didn't really show any pictures of the cone. We haven't actually hiked all the way up to it, because you end up going up and down all these big rolling hills, and I've never convinced anybody that it was worth hiking all the way there and doing all that up and down. At one point, I was about a half mile ahead of everybody, and they all just stopped, and they're like, "We're not going anywhere any closer." But you can see the cone of that particular eruption. And there are some other remnant volcanic cones in the area that you can see. I didn't really point them out on the map. Our imagery up here is really bad, so you can pick it out if you know exactly where you're looking, but just sort of casually, it's harder to see.
Any other questions for Paul this evening?
Hey, Paul, you said you weren't a biologist. Do you guys ever collect any samples though for other external biologists?
I did collect some samples in Valhalla for Diana Northup, ones that look like they might have the actinobacteria on them. And she said that since she's doing it kind of the analysis for free, it's always on the back burner. But she said they did detect DNA in there, but they have not sequenced it yet. I do think there's more opportunities for some of the microbial stuff, and I do think that it would be a great place for someone who's into the invertebrates to go in and do some detailed invertebrate stuff, because I would be shocked if there were not some endemics and new species up there in the lava tubes. It's a whole field that has not really been looked at. I mean, nobody goes to this area. No sane people anyway.
That's awesome. Anybody else?
That name, Diana Northup, isn't she, hasn't she worked with Michael Taylor around here, around a secret squirrel cave in Tag? I remember reading her name in his book.
Yeah, well, she's a pretty famous microbiologist. So like he references her a lot in his Cave Life book. But she doesn't even fashion herself as she's not really an exploration caver. She is a science caver. And that's she professes that herself. She's been in Lechuguilla, but she actually does not like doing vertical work, and is very happy to let other people go in and collect samples in the far reaches of Lechuguilla for her.
Very cool.
She's a fantastic person.
Oh man, great talk. Any more questions tonight? There's been some good ones. Oh, sounds like we're running down. Paul, I guess the only thing left is just to let me know the next time you're going. Since you did this amazing talk, I guess I owe you. So I guess I'll come out with you and survey some.
Yeah, I'll twist your arm and come out and map some sharp little lava tubes.
That's
I can
right.
guarantee you that there won't be any muddy belly crawls or near sumps that we'd be going through.
Just
So
some watery swims, it sounds like.
yeah, but you know,
Way back.
yeah, it's one of those that's the water's so cold you're not really tempted to do it. I've done plenty of mapping there in Kentucky that where I'm just wearing tights and a polypro shirt and swimming passage, and I'm perfectly happy with that. But I draw my line at about 45 degrees as far as casual swimming without a wetsuit.
Right.
At least if I'm surveying.
True that. All right. Well, thank you again, Paul, for coming. We'll let you get back to your lunch break. I guess that's what time it is in Alaska.
Well, it's 5 o'clock here.
I didn't think it was that bad, but yeah. So sweet. Anyway, if you will, you can stop sharing your screen.